In this video, I will commentate on how to remotely run your ROS2 MoveIt application to a robot arm. From my last video, I demonstrated a concept of putting a robot arm in the kitchen to help with cooking. In order to achieve this, I have to transport the image layer from the Raspberry Pi that sits on this robot arm to my other beefy computer so I can run some image classifier, as you've seen here. What I basically did was setting up a motion JPEG streaming server, and I have a service that listens to this address and then transport it into a ROS image layer. Here's a quick architecture diagram. After transporting the image into a ROS image layer, you can then use a subscriber to subscribe to the image topic, and then you can do something fun like using the YOLO detection on this. I found a Coco dataset and trained on it, but it wasn't perfect, and I'm a little bit lazy to train my own dataset. So I was just using this to kind of demonstrate that I could detect some fake vegetables. Now, when I was controlling the robot, I was just using their Python API to do several controls, but I need a way to control it via MoveIt, which is a ROS2 application that can do motion planning. And in order to do that, I need to expose these API into the ROS layer. So I did a similar thing in setting up a server.py on the Raspberry Pi. And here's a quick diagram for it. To be specific, I'm using TCP with a socket port open, and the reason why is because I needed to send these raw bytes to control the arm. And the TCP guarantees every byte arrives at all. It also retransmits anything that's lost in the transit and without any duplication. I also needed an accurate 3D model of the robot arm and the gripper itself so we can translate it into a URDF file, which the MoveIt will use it to control the joints and detect these collisions with a mesh. Now, thankfully, the Elephant Robotics already has these files for me. The only downside I had was we did not have the flexible gripper representation, so I used another gripper model that's slightly different, but it serves the purpose for just grabbing and opening the claw. Oh, one more thing I needed to do is having an accurate environment to the robot arm. So in this case, I have a shelf on the top, you can see in this video, and a wall at the back of the robot arm, and then a table. So I need to accurately translate this to the MoveIt. So when it does motion planning, it will make sure it doesn't collide on the next step. Here's a quick demo on my beefy computer that has access to the robot arm remotely. So this is a web server that you see with the stream of images. And then I open the MoveIt. The green plane that you see behind is the representation of the shelf and the table. And then here I was just testing different poses that I created to see if I can control it correctly. One thing you would notice, the gripper is kind of disconnected from the end effector itself, and that's because my gripper is a flexible one and it's slightly longer. So in order to model that, I just made it a little bit forward. For the robot arm position, I allocated several goalposts that the robot arm can always return to. There's 2 spots on top of the shelf, and then one on the kind of the counter, and then the one near the pot. So these are the robot position that they can always go back to. From there, I basically let the MoveIt dictate the motion planning. One of the cool thing is when it needs to go from the counter, the table, up to the shelf, it'll do this kind of a snake 360 motion that you've probably seen in my last video. And I thought that was pretty cool without colliding with the walls. And that's why you need a pretty good measurement of the environment. And that's so far what I have. This project took about 2 months. The development time was really long. But I'm very happy to at least make some application out of it. My thought was to grab this robot arm and do some training in Isaac Sim and Isaac Lab, kind of what you've seen with reinforcement learning, imitation learning. But I think this will probably take another 2 months, and at this time I'm just really too busy with other projects. But I think it'll be really cool application once it's done, and I'm making all these code available for free, so you can play around with the simulation or the robot arm itself if you have one. And part of this goal is to really see, can I do some cooking with a robot arm? So I probably have to simulate that in the simulation. And I think it would be cool if it can start chopping vegetables, although that's probably not advisable if you're doing this at home. Yeah, so that's about it for this video. I hope you enjoy. Please check out the other few videos that I've done with this myCobot 280. And thanks again for Elephant Robotics for sponsoring some of these accessories. Let me know in the comments, what do you want me to do next, or any other project ideas. And until next time, I will see you soon.